In this lesson, we're going to go from a sparse matrix to a full matrix. First, I'll show you how to create an empty data frame that we can populate with values later on. And then we will write the Python function that will do this transformation from sparse to full matrix. Let me add a quick markdown cell here that reads how to create an empty data frame. Now, why might you want to do this? Well, sometimes you want to create the data frame first and then populate it with values later on. The key things that you need, of course, with this is you need to specify what sort of column names you want, how many columns you want to have, how many rows you want, what the index names should be, and perhaps also provide some sort of dummy value for the cells, right? Do you want the cells to be equal to 0 or none or 1 or something else? Let's tackle one thing at a time. Let's start with the column names. So I'm going to create a variable that will hold on to all of these. Column underscore names is going to be equal to square brackets, single quotes, doc underscore ID. So we're going to have our document IDs, for example, as a column. Then we'll have a plus, and let's add the category as well. So square brackets, single quotes, category. And then let's add our word IDs that go 0, 1, 2, 3, 4, all the way up to 2,499. I'll pass this in as a range. So list, parentheses, range, parentheses, 0, comma, vocab size. Our vocab size is saved as a constant up top. If you want to take a look at what the first 5 columns will look like, they're going to look like this. Column names, square brackets, colon, 5. There you go. So as you can see, we've simply created a list that starts with 2 strings and then some numbers from our range object. Now, of course, the list is quite long, right? So len parentheses column names shows us that we've got 2,502 columns. So 2 additional columns plus the number of words in our vocabulary. Now for our index names, so index underscore names, we'll use maybe the unique values of the different document IDs in our sparse training data. So I'm going to do this with NumPy, so NP, and I'm going to use the unique function from NumPy. And I can specify my sparse training data here and select one particular column of this NumPy array with square brackets, colon, comma, and then 0 for the first column. Index underscore names now looks like this. 0, 1, 2, and then the last 3 values are 5791, 5794, and 5795. Now mind you, these are not in numerical order, of course, because some of the document IDs, of course, belong to our training data and other documents have been excluded, as we've seen in the last lesson of the previous module. All right, so with these 2 things in hand, we can say create a data frame like so. Full underscore train underscore data is equal to PD for pandas dot data frame parentheses, and then we'll specify some arguments here. The index is going to be equal to our index names, and the columns of this data frame are going to be equal to our column names. Fair enough. Easy, right? So let me hit Shift Enter on this. So we'll run for a little while, and we can look at our head of this data frame and see what it looks like. So this is interesting, right? We've got NaN, not a number, NaN values for all the cells. What if we wanted this data frame instead to be filled with 0 values as the default instead of these NaN values? Well, we can do that with a handy little function called fillNA. So we can take our data frame, put a dot after it, and write fillNA, parentheses, value equals 0. This here is a method from the pandas data frame that allows you to fill a data frame using a value of your choice. We will fill this data frame with the value 0. And we're also going to use this in place argument here. So instead of writing something like full underscore train underscore data is equal to full underscore train underscore data dot fill NA, we will use in place to just replace our existing data frame. In place is equal to true. There we go. So I'll hit Shift Enter on this, refresh this cell, and then let's take a look at the head of our data frame. Voila. Instead of the nan values, we have our default values equal to 0 now. Now let's create a full matrix from a sparse matrix. So we've imported our sparse matrix earlier from the txt file, and let's write a function that will create our full matrix for us. Now remember, the structure of our sparse matrix was document ID, word ID, label, and then occurrence of this particular word. That's the structure that we're working with. These are columns 0, 1, 2, and 3. So let's define a function. Make underscore full underscore matrix. And this function shall have quite a few arguments. The first one, of course, will be the sparse matrix that serves as the starting point. The second argument shall be the number of words, nr underscore words, in the vocabulary. The third one, maybe the document index. So our document IDs are at index 0. So I'll say doc underscore index is equal to 0. So I'll just give that one a default value. Then I'll specify as well what the index is for the word, right? So that way we don't forget. The word index was 1. The category index was 2. Cat underscore IDX is equal to 2. And lastly, our number of occurrences, our frequencies, frequency underscore index is equal to 3. This here is going to be the signature of our function. Here's how I'd like it to work. I'll add a docstring with 3 pairs of single quotes, and this will read form a full matrix from a sparse matrix, and it's going to return a pandas data frame. The keyword arguments that we've specified above are as follows. So the first one was the sparse matrix, right? So this will be a NumPy array. Then we're going to have the number of words, which was the size of the vocabulary. In other words, the total number of tokens, right? The document index is just the position of the document ID in the sparse matrix. And by default, it's the first column. Now I'll add the description for the other keyword arguments as well. And by the end, I'll have a brief description of what this function should do and how one should use it. This is handy for ourselves who might be looking at this code in the future and not remembering how it works exactly. And it's also handy for anybody else working with our code. And in Jupyter Notebook, when you press Shift-Tab, the docstring is what you see pop up. Now, how are we going to do this? Well, let's first start out with an empty data frame. We can reuse some of this code that we've had above. So I'll just copy this line here, paste it in for the column names. I'll copy this one here, paste it in for the index names. But I'm going to rename this instead to document ID underscore names. I think that's a lot more helpful. And we also got to make sure that we replace sparse underscore train underscore data with our parameter here, sparse underscore matrix. Otherwise, we're going to have a big problem later on. So there you go. Then I'll copy these 2 lines of code and I'll come down and I'll add those in here. Now, one of the things that you always want to check in Python is the indentation. Here, I'm working within the body of my function, but here I am not. So I'm going to move this over a bit so that I'm within the body of the function. And then I'm going to have to change my index names to document ID names. After all, we've renamed this on the line above. And then at the end, I'll return this full matrix right here. In between these two lines of code, we're going to be doing all our work. We're going to be populating this full matrix. Here's what I've got in mind. Our sparse matrix kind of looks like this, right? We've got 4 columns and they're labeled document ID, word ID, category, and occurrence. Now, what I'm after for the full matrix is something like this. I want the document IDs in one column, I want the categories in one column, but then I want the word IDs as separate columns, and I want 0 values for all the words that don't occur. In other words, the frequencies or the occurrences of the individual tokens will of course be in the rows below the word IDs. Here's a fuller picture of the data frame that we're going to populate. Every single token has a separate column in this data frame. These columns go from 0 to 2,499 because we've got 2,500 words in our vocabulary. Now, of course, many of these columns will be equal to 0. But what we're going to do is we're going to go through our sparse matrix row by row by row by row, and we're going to populate the entries of our full matrix, which are non-zero, with the correct occurrence. So without further ado, let's get started. The way we're going to go through this sparse matrix is with a loop. Now, I'm quite partial to the for loop. So for I in range, it's going to go from 0 to the number of rows in the sparse matrix. So that's going to be sparse matrix dot shape square brackets 0 colon at the end. Now let's grab the data that's in each individual row. Our document ID, or our document number, if you will, is going to be equal to sparse matrix square brackets I, so the ith row, and then it'll be the first value, so it'll be 0. The word ID is going to be sparse matrix square brackets I square brackets 1, right? Our label, the category, will be the sparse matrix square brackets I square brackets 2. Now, what you can see is that for these hard-coded values, we can actually use the parameters that we specified above. So for our document ID, I'll replace the 0 with doc underscore IDX. For our word ID, I'll replace this 1 with word underscore IDX. And for our label, I'll replace this with cat underscore IDX. The occurrence is of course equal to sparse underscore matrix square brackets I square brackets frequency IDX. These 4 lines of code here store all the values in a particular row in 4 separate variables. If you'd like to see this square bracket notation in action, I can show you what I'm planning to do up here. So if I take our sparse training data and say we look at the rows between, 10 and 13, in that case we'll see these values printed out here. What we're doing with our sparse training data, our NumPy array, and this square bracket notation is we're going to a particular row with, say, 10. So this will be the value of I. And then for that second pair of square brackets, we're selecting a particular value. So if that value is 0, we're getting the document ID. If that value is equal to 1, we're getting the word ID. For 2, we're getting the category. And for 3, we're getting the frequency. This is all we're doing inside of our loop. Make sense? Now that we've extracted this data from a particular row, we can come down here and we can populate our full matrix with data at a particular cell. So full matrix dot at square brackets document number, comma, single quotes, document ID, and single quotes, end square bracket, is going to be equal to our document number. Full underscore matrix at square brackets document number, comma, single quotes, category is going to be equal to our label. And full underscore matrix at square brackets document number, comma, word ID is going to be equal to the occurrence. Now, if these three lines look a little bit mysterious, what we're doing here with .at is we're selecting a particular cell in this data frame that we've created. Which cell did we select? Well, the second value here is the column name. So this one here will always go to the document ID column. This one here will always go to the category column, right? And this first part here is the row number. So the row number will correspond to the document ID from the sparse matrix. So we're selecting a single cell here, and then we're setting its value. The document ID, of course, has to go in the document ID column. The category, of course, has to go in the category column. And the frequency of a particular token is going to go under the word ID of a particular document in this data frame. And this pretty much completes the body of our loop. We're grabbing the data from our sparse matrix, and we're populating our previously empty data frame inside our loop. The only thing left to do is maybe set the index, right? So full matrix dot set underscore index is going to be equal to the document ID column, single quotes, doc underscore ID. And as a second argument, I will provide in place is equal to true. Okay, so let's hit Shift Enter on this and try this out. I'll include our benchmarking code here with %time in the cell below. And then I'll create a variable which will hold on to our full matrix, full underscore train underscore data. This is going to be all our training data. And we're going to make a function call to make full matrix. And in the parentheses, we'll provide our sparse training data and our number of words. So our vocabulary size, vocab underscore size. Let me hit Shift Enter on this. This should take 10 to 15 seconds to run. There we go. Now let's take a look at the head of this data frame. See what we've got. Full underscore train underscore data dot head. So the good news is that this is kind of what I've expected to see. I've expected to see far more occurrences for the frequent words with word ID 0, 1, 2, 3, 4 than I see for the less frequent words with the word IDs close to 2,500. And this is the pattern that we should also see in the tail of our data frame. Brilliant. In the next lessons, we're going to start training our naive Bayes model. In particular, this means calculating the probabilities for the individual tokens. This is where all the probability theory that we covered in the previous module comes into play. I'm pretty excited about this, so I'll see you there.